And the reason we kind of picked these three as sort of our driving tenets was exactly what you called out, right? If you look at core problems that customers deal with around, and the reason we kind of picked these three as sort of our driving tenets was exactly what you called out, right? If you look at core problems that customers security deal with, around maintenance and otherwise, part of it is driven by the fact that they assume this thing is alive for a long time. The longer it stays, the more craft it enables, the more complicated it becomes.
Hello, hello, hello. Testing, testing.
The more complicated it becomes.
Hello, hello, hello. Testing, testing.
The more complicated it becomes.
Hello, hello, hello. Testing, testing, testing. Hello, hello, hello. Testing, testing.
The more complicated it becomes.
Hello, hello, hello. Testing, testing, testing.
Comes to spread the workload around, right? Like you get into say things like affinity and state, which gets far more complicated. The entity becomes addressable, not just for your attachment purposes, but for security purposes, right? And security is like a really top tenant. It is the top tenant for us as we're building through, and it's one that we want to pass on to customers on that particular front as well. And for me, people often say, "Oh, you're saying ephemeral. Ephemeral means not durable." For me, it's more the temporal ephemerality of it. Like it exists, but it only exists for a short period of time when you need it to exist. And I'm not saying that means there's a finite. As long as there's a finite bound to existence, that's what matters, and that's sort of human concept. So if I start saying, oh, it's finite bound, but it's bound for a month, you're kind of breaking the model a little bit over there, right? But like 15 minutes, 30 minutes, an hour, like sure, that's within bounds. Like that you're still within bounds of things being cycled and cleared out and going out over there. And like you said, the same thing with tenancy and isolation, right? Like one request, one execution environment was driven by the same thing. You need consistency of performance. That's a hard problem to do in distributed systems. You need isolated resources to run and execute the code that you're doing. That's a hard problem to go solve. You can enable multi-tenancy, but again, like you said, it sounds great in practice, and there are a whole bunch of patterns you have learned in the past that do it really for efficiency reasons, right? Like the funny thing I keep whenever I talk to people about multiple requests per execution, they're like, well, it's because it's cheaper. I'm like, great. So what if I made it cost you, 1 cent per billion? Is it okay then? Or they're like, oh yeah, then I don't want to write multi-threaded code. I'm like, great. So let me do that then. I'll make it cheaper for you rather than forcing you to write multi-threaded code on that particular front. And it's that combination for it. And for me, the last bit that Lambda does really uniquely even now is saying you deal with resources. You get CPU, you get memory, you get compute, and your code is the thing that's important. That's the addressable thing, not the resources. You're not binding your function to a collection of machines or a pod or anything that's addressable. You're just saying, I want this much memory every time it runs. And whether I spin up 18,000 cores in the back end or 1.8 cores, that's not your problem. That shouldn't be something you worry about, where those cores exist, where all that happens. That's going to be the driving philosophy of it. And again, the whole idea is the less things you have to think about from a distributed computing perspective, more than what you need to build and deliver value to your customers.
Right. Yeah. And so the other thing, the other piece of this is that you provide all these primitives, and capabilities. And I love this idea of democratizing, compute, because that's one of those things where I remember long ago, just having to order racks and racks of servers from Dell and paying thousands of dollars a month in order to put them into a co-location facility somewhere. I mean, even just EC2 instances and VMs. I mean, that was a huge step forward where I remember I was paying, I don't know, something like $5,000 or $6,000 a month just to run a co-location facility. I moved it all into EC2 instances and it dropped to $700 a month, right? I mean, just that huge shift there. But now we're not even talking about $700 a month. We're talking about, maybe $1 a month if you're building a startup. I mean, you can get so cheap to do this that now the barrier to entry is incredibly low. But there's a caveat. There's always a but to these things. And that has to do with, one of the philosophies you mentioned was personal productivity. And I find this to be one of the most frustrating and the consistently frustrating. The thing I hear from other people I talk to all the time is the frustration over developing serverless applications. There's SAM, there's serverless framework, there's Claudia JS, there's Begin, the architect framework. There's all these different ways that try to make it easier for you to build serverless applications. But one of the complaints that I've had, and I know other people have had this complaint, is that, AWS isn't always the best with tooling, right? I mean, the tooling is somewhat disconnected. It's not always.
Yeah, this is a very interesting one. I think something that Jeremy Daly is getting at is that the ISC framework market is pretty large. And so you have things like AWS SAM, Terraform, CDK, Architect, Serverless Framework, Raw CloudFormation. And then when it comes to actually choosing which ISC framework you actually want to use, I think that's where we see a lot of contention and a lot of people trying to figure out what is actually best here. And so I think something that is kind of interesting is where does AWS fit into that model? And is it AWS Amplify? Is it AWS SAM? Which ISC framework is actually going to win out at the end of the day? And which one makes it the easiest to actually build serverless applications? I think that the future, in my opinion, is it's diverse. So I think what that looks like is different companies will have different skill sets based on what the expertise that they built internally. I don't think that any ISC framework currently is going to just disappear. So I don't think that serverless framework or AWS SAM or CloudFormation in itself for CDK, I don't believe that CDK is going to win out over the rest of them, or serverless framework is going to win out. I think that each one of those has a place, because even if you're transitioning from non-serverless workloads, you still have to build that infrastructure as code. And then as you do that, your team builds up expertise in it, your people are trained in it, and then as long as those IC frameworks are developing continuously along with the growth in different serverless offerings, such as, like, let's say Terraform is continuously growing the actual functionality side of it to keep up with AWS and other cloud providers, then I think at that point it'll still have a place in the future. And I think that any IC frameworks which don't continuously adapt to the changing environment, those ones may be pushed aside, and then the companies might then go, okay, what is the value proposition of switching? And it may be higher because the functionality they need is no longer supported. So yeah, that's my opinion on that.
Always consistent. But that's something where, I mean, and again, I'm not even sure there's a question in here, but just more along the idea of saying, I get that that's a tenet, and what are the plans? What are you planning on doing? I mean, to bring that, to make people more productive. I mean, obviously, I think the container aspect is one thing, right? Meeting people where they are, giving them more capabilities. But what are the other things maybe that you're trying to do or have done that you think are sort of solving that problem?
As you can imagine, Jeremy, this is one of the top things that keeps me up at night as well, right? Like, how do you make, on one hand, we're saying we're about making builders more productive. On the other hand, the feedback we hear is you're not doing enough. Like, you have to kind of keep pushing the bar over there. And there's a lot of things AWS does well. I think we're really good at building services and growing them. But when it comes to aspects like developer experience, and this is where the personal productivity aspect comes to me, I think the nice thing about the philosophy, at least my team follows, and I know AWS overall does, is we can't do this alone, right? Like, it's not easy to go in and just say, this is the way you're going to do it, take it or leave it, and then get out of the way, right? And that's fine. That'll always work for a niche audience. But if you want to go broad with your story, it has to be something that you do in combination with others. So I think for me, a big push, that's kind of where the big push between the runtime API, container support, and even extensions comes in, right? Like, how do you get the rich ecosystem of partners around AWS to help customers solve that problem and kind of do better on that particular front? So I think that's one. I think I'll go back even to serverless framework, right? Serverless frameworks was actually put out by Austin and Co first, even before Sam and others came out, right? Like, and that was one big enabler for the early drive around it. And that was a really nice innovation out there. It kind of started tackling the problem of standardizing and deploying serverless applications that inspired a whole bunch of other tooling pieces that came around as well. So that's one. I do think serverless has a unique challenge where you kind of have, there's a new conceptual learning that you have to go through. Applications are built composed of services talking to each other through APIs and events, where there really is no defined pattern. So you're now starting to create tribes, right? So you have a bunch of people who are like, no, this should look and behave exactly like web frameworks, and I'm trying to build end-to-end stuff. And you have kind of the Claudias and others show up over there. There are others who are like, no, I'm just going to treat this as a general purpose, slightly better infrastructure as code story. And that's where you kind of have the SAMs and the CDKs with their own tabs versus spaces debate that is kind of sparked off over there, right? And I would say the real big opportunity, and I actually really like what the Begin and Architect folks are doing over here, is starting to sort of embrace that serviceful nature of it and go, how do you make it easy to compose services together and build forward and do more over there? And I would say that's what you will see, the place you will see AWS potentially invent. And I do this pretty across our services, is when you start seeing commoditization of these particular patterns, right? So that's kind of what happened with SAM. We saw every single tooling provider going and saying, I need a way to express a serverless application as a combination of services. We're like, okay, all of you don't solve it 10 different ways. We'll do it. We'll give you a default standard CLI, but by no means are we saying only use the SAM CLI. It's an easy and default way, and we're going to keep trying to make it better. But there's always a rich ecosystem of tools that you're going to go and do over there. Same thing with diagnostics. With extensions, you've gone past CloudWatch. You now can use Datadog and New Relic as much as you do over there. So I know I gave a non-answer to your non-question, but the whole idea is that I think we're not going to be able.
Yes, I think it's kind of interesting what was said there around kind of what kind of sprung up after serverless framework. AWS SAM came later. Other patterns came after that for IC frameworks. It was kicked off by the serverless framework to a large degree. Now we're seeing Vercel and Begin. There are different ways of creating serverless applications, and in that way, some of them have a little bit better tooling. And what that enables is that you're going to have more abstractions over the infrastructure as code side. So now developers may not need to understand as much of the CloudFormation, intricacies of that and like the nuances of writing CloudFormation or infrastructure as code. And serverless framework does a good job at that, but you still have to understand quite a lot. Based on that, serverless components is a new feature release from serverless framework, which helps on that factor as well. But then you have other providers that take it even further, and they're abstracting over AWS SAM. You have companies like Stackery, for instance. They have a drag and drop UI, which allows you to do that. You have Vercel, which has a simple CLI where you just deploy with like one command and you can get stuff up and running. And there's a whole bunch of other companies that are all developing similar aspects to that. And they're all trying to tackle this developer velocity side of things, of how do you basically enable developers to move faster, and how do you make sure that their standards And something that he mentioned there was that there aren't really standards, right? So it's kind of like a do whatever you need to do to make the thing work. You can do it manually in a console. You can see it. You can do it with an IC provider. There's a lot of different ways that you can kind of achieve the same result, and there's a lot of frameworks out there. There's a lot of new tooling that will be developed in the coming months and years. And so I think something that they're getting out there is that maybe amplify as well as a SAM CLI. There's like there's sort of a part where they're just trying to tackle the simple use cases, and they're kind of needing the outside community to take it a little bit further maybe than they can do. And I think AWS is in an interesting spot because they make the services and it's that foundation level of services. They have to accommodate thousands or tens of thousands of different use cases if there are that many. And with each one of those use cases comes new problems. It requires different tooling, different functionality, different features, and they can't fit all of that in. And so that's where the outside community has to go, you know what, we do machine learning for the specific niche, and so there's tooling for this, and we built a platform around that. We do serverless development for REST APIs. Here's a tool that makes it really easy to do that. We build AppSync APIs. Here's a tool to do that. And it's not that, you know, one tool to rule them all. It's more like based on the sheer number of things that you can do with AWS, different companies have to address these. And there are foundational pieces, like I mentioned, serverless components. Those are starting to become more like Lego blocks of building cloud applications. And I think that we're starting to see that with a few other things as well. Essentially, the development of CDK and AWS creating CDK patterns, which can be used and leveraged. If you have enough of those CDK patterns, you have enough of the other types of templates like serverless components, and you can stitch those together, then you can create a standardized library of how you would build cloud applications. And so I think that that's a very interesting point which got brought up. And yeah, let's continue from there.
To be able to do this alone. This is going to be an ecosystem story over there. AWS has to get better on offering more vertical solutions in these particular things, and I think that's kind of where the space you will see us investing more. I love what the Amplify team is doing. That's my favorite example of a good, simple experience that they're able to do with good defaults, end-to-end experience, focusing on a single use case.
Right. Yeah, and that is always where again, my criticism is only because I want it to get better, and I think that the constructive criticism is always good. But AWS is always very good at building these stacks of these stacks of services, like these services that do a very, very good or simple thing. And I guess that's like you mentioned in your talk, this idea of application primitives as a service, which I think is a really good sort of way to think of it, where you've got your compute and data, you've got your integrations, you've got your tools, security and admin all baked in. I think those are great things. But you mentioned something that is probably is the hardest thing to explain to people sometimes. And you said about Architect sort of doing a good job of connecting services. Cross-service connectivity is extremely hard. It is not an easy thing to do, but also to grok. I mean, just to understand how service X connects to service Y, and then of course the observability challenge that's in there. But so just a little bit more on that. Like I know there have been things that launched at reInvent in this past year, but what is AWS doing to make that easier?
Oh man, I think this is actually something AWS just needs to solve on our own. Right? This is not a tooling or ecosystem problem. We own the services, we own the interfaces between them. We have to make it easy. So as with all things, security comes first. So you will see sort of this consistent.
Yes, I want to pause real quick to touch on this. I think that it's kind of an interesting question that got brought up here from Jeremy Daly, which is like the AWS side of knowing how these services connect together and then being efficient at that. That is a tricky problem, and it's not something that's straightforward. And so I think it's just one of those things where you have so many distributed teams at AWS, it seems like, that trying to make sure that the documentation fits together, all the different terminology fits, all the vocabulary fits, the coding style, the console style. There's a lot of, even if you go into AWS services, the consoles may look different, documentation may look different. And so trying to stitch that together and then fill in those gaps, I think that's where, I definitely agree with Ajay here that, if AWS can help solve that problem, that'll go a really long way, especially when it comes to getting more serverless adoption and bringing that into the future, because then more people will be able to get an easier start, and there'll be less barrier to entry because people won't be stressing over how these things fit together and potentially getting swayed away from actually building more things with AWS or with serverless, because things kind of come off confusing and not so much straightforward. So
consistent pattern of resource-based policies between each one, IAM-based roles policies between each one, granular tenants being talked about each one across the spectrum of services that can talk to each other. I think for me, the next big one is around sort of these reliability controls, right? So the DLQs, the checkpointing, and others that enable to kind of go and do over there, because a message, you need to know who you're talking to. You need to be able to talk to them securely. You need to be able to get the message to them quickly and in a reliable fashion, and you're sure that it gets one to the other. And I think then it opens up this pattern of saying, now what are the new sort of line-specific use cases that you can enable, right? So this is where your batching, your replays, your aggregations, time windows, and all of those show up. But because you own both sides of the equation, that's kind of where the power of AWS can really come in. Like, we're really good at doing reliability, performance, security, scale. Like, we should make that as much as possible easy for you to do. I think my prediction for you is, I would say you're going to start seeing a far more consistent API-driven story for enabling all these controls across all these connections. You're going to see less and less of this required to be solved at a tooling level, and more of this being solved at the API level within the AWS services. And even for the broader set of services to participate in this, I think that's where EventBridge comes in, right? Like, EventBridge has to encapsulate all these connectivity as a service capabilities. Right. And so that if you have your own SaaS service and you're like, well, in order to talk to an AWS service, I need these, security, availability, reliability controls. You just plug into EventBridge, and that gives you all of that in a box. But for all the other connectivity, it should just be part of the API, right? Like, my dream is the event source mapping that we have for Lambda just sort of universally works for any pattern that you see out there. X-ray just flows end to end within the service. Tracing is enabled by default. Logging is enabled by default. But you need a North Star to keep going towards it. And as with all things AWS, it comes together quickly and over time.
Yes, this was an interesting one that he just brought up. It was around X-ray and how there's a lot of different dials that you have to turn to make things work currently. And so, one thing I think was the IAM resource policies. So for instance, if I wanted to make X-ray work, I might have to enable something. If I'm using serverless framework, I'll enable something there for the Lambda function. I then also have to give the IAM permissions to be able to access it for the traces. And so I think what he's kind of getting at there is that potentially that side of it, the extra little dials that you have to turn, the DLQ side of knowing to even enable it, those things may be done by AWS in the future, it sounds like, which would streamline developers that are trying to work with this functionality. Because right now, if you open up the Lambda console and you look at all the various things that you can actually do, there's like way too much input. There's capping concurrency, there's IAM permissions, there's the connection to the Lambda and where the Lambda function is going. There's memory concerns, there's CPU concerns, there's the code aspect, of course, and there's Lambda extensions, there's Lambda layers. Gosh, there's a whole bunch more that I'm probably not even thinking about right now, but the big thing is that the more things that you can do, the less approachable it becomes, because there's so many things that kind of get thrown into your I guess like your space when you're trying to figure out how to build things. And so when it comes to things like, when do you use a Lambda extension versus a Lambda layer? Is a Lambda extension just a Lambda layer? What's the difference there? How does that work together? How do I make sure that my packages are optimized, and what solution am I using there? Knowing those things is not straightforward, and if you do need to solve it, the more things that you add around it, that might increase the complexity and the amount of input that someone has when they're looking at these things. It just makes it more difficult to solve those problems. So the faster that we can get past these like kind of small intricate things, like I enabled X-ray, but then I didn't have the right resource policy on it, and it didn't know that automatically. And because of that, now I'm spending time debugging something that should have maybe been handled by the provider. And because of that, I can't spend time on optimizing my functions to have smaller packages. And so it's delayed a little bit. And each one of those, shortens the amount of time that we have to actually release the software on time and hit our deadline. And then by the end of it, we're in production, or we're right up against the deadline, right? And then we have to kind of rush things out to get things finished. And that's when things get skipped over. That's when you have production issues downstream. And so for the idea that some of this stuff is getting solved, I think that people that have been in the space for a while, they're going to see huge benefits of that, and that people that come later, it's just going to naturally work and probably take it for granted, similar to my career so far, working in cloud and kind of skipping over some of the Docker containers and virtual machine setups and even on-prem stuff. So yeah.
Right. Yeah. Well, and I think you mentioned too the API economy in your talk, and I think this is fascinating. And I know one of the developer advocates, I think for the Amplify team, had written an article about sort of a big difference between sort of the haves and the haves not in the API economy a little bit, and that's probably a longer discussion. But there are a lot of APIs. People are building serviceful applications now. That's just the way that it's going, right? So you have this idea of saying, look, if I want authentication, I can get that from Cognito, but I can also get it from Auth0. And if I want email as a service, I can use SES, I can use SendGrid. If I want SNS, I can, or I want SMS, I can use Twilio, or I can use SNS. So there's all these different services that are there. But what I think is really interesting in terms of what can be done, and you mentioned this, is that interconnectivity between those services where your everything is in silos right now. So you say SNS is a service, and I have to understand the nuances of interacting with that particular service, like it is with any API. And that I think is a huge opportunity for AWS to say, if you just need a queue, you just attach Lambda to it, and it just handles all those things that you would want it to handle, and you're not writing all that code, right? Just reducing the amount of code that you're writing. And again, I don't know if there's a question in there, but just I think that's really interesting.
Yeah, I just wanted to comment on that because I think it's actually a really good point that just got brought up around the code side of it. We see this with Serverless Guru has some stuff on our blog about API Gateway Service Proxy and the ability to basically remove the Lambda function and then talk directly from API Gateway to SQS to then put messages into a queue, which then gets a Lambda function invoked after that. And you can do the same thing with DynamoDB. You can actually have an API Gateway Service Proxy that then forwards or then writes something to DynamoDB. And we've seen this with VTL templates with AppSync as well. So we have VTL templates, that same type of style with API Gateway. AppSync kind of brought it more into the light, I would feel. And it kind of put a spotlight on how you can remove the Lambda function to have this interconnectivity between services, as Jeremy Daly pointed out a second ago. And so I think that there is a big market in the future for solving that problem, where the actual code that you use to communicate between Lambda function and DynamoDB, Lambda function SQS, SQS to Lambda, and the actual order and the sequence of things that happen, it's very similar. And so the same way that we're now getting to a point where the application code spread out over millions of different developers, it all looks really similar. And so I think if, let's say, one example of that would be taking the SQS queue, and then the message that's getting in the SQS queue invokes a Lambda function. The Lambda function has to do a series of steps. The first one is to filter the message that's coming out of SQS, right? DynamoDB has a trigger on it. It triggers a Lambda function. The first thing that comes out of that is basically an if-else statement saying, is this an update, a create, or a delete, right? It's very similar. It's the same thing, API Gateway. Let's say you're doing a monolithic Lambda approach. It comes in, what's the path, what's the method, where do I route it to? What's the actual handler code, right? So there's a lot of boilerplate in each one of these scenarios. And right now, I feel like that's being duplicated across millions of developers. If there are millions of developers writing serverless applications, which there may not be, that would be an area that's probably being duplicated a lot. And so I think the idea there is, even if I wrote an API Gateway implementation today, and then 2 months from now wrote an API Gateway implementation, I would probably be solving the exact same problem, and I might even not know that I had an example of that in the past that I could copy from, right? And so it's the same thing with filtering an SQS message. I now have this knowledge of how to do it, but even my future self in 2 months from now may rewrite that same code, and then I may have to debug certain parts of it because when you're writing it, because the abstractions aren't there, or you could blame it on the deadlines that you have, strict deadlines to not automate things enough or build the abstractions, you can end up creating a scenario where you're basically writing very niche code to the specific use case that you're solving, and you're not thinking about the future when 2 months from now you're having to do the exact same thing again, or spread that over 30 developers, and every couple of days someone's having to rewrite that same use case. It just opens up this whole thing where there's so much code that's not needed for the actual specific use case that you have, right? So let's take an example of this even a little bit further. Let's say sending an email. The only thing that you might actually do, which is different, is let's say you have a DynamoDB trigger, and then it's a Lambda function, and then it goes to SES, right? And then sends an email. One thing that's going to be different between the hundreds of, thousands of developers and the hundreds of thousands of companies is the email, right? Like what email address is it being sent to, right? That's one thing that's going to be different. The schema of the DynamoDB database, that's going to be different. So and then the business logic in between the DynamoDB event triggering and then the email being sent, if there's any other special things like another HTTP API call in between that, that's going to be different. But the filtering of the DynamoDB message at the very beginning and the SES call at the end, except for the email address and potentially the table name, which you may not even need in that case with the event triggering the lambda function, those two things on both ends are going to be pretty similar. And so I think for a lot of use cases, people might be able to get away with having an abstraction on the incoming event and an abstraction on the outgoing response, and then having some type of library for handling the business logic side in the middle, or writing just that custom piece. And so what I'm kind of getting at here is the gap at the moment is abstracting things enough where as a developer, I don't have to worry about rewriting the filtering code at the very beginning of the Lambda invocation and the last step at the very end of that Lambda function. So that's something that I'm interested by. I think that other people are interested by it as well that are working on solutions for it currently. So it'll be interesting to see what comes in the coming months and years. But I think based on what Jeremy Daly's saying and Ajay's saying from AWS, it sounds like it's a problem that a lot of people are thinking about, which is, what part of we've abstracted a lot of the infrastructure and, the virtual machines, the Docker images, things like that. But what else can we abstract away? And now that we're focused on the application code, instead of all the underlying things that we had previously, now the application code, there's opportunity to actually abstract that further as well, without having to sacrifice like flexibility. And yeah, so I'll leave it there.
Interesting, as especially considering the fact that serverless to me is more serviceful now, right? That's really a good way to think of it. It's just, what are the, maybe just for the benefit of the users or people who are not quite convinced yet, why is this sort of serviceful movement such an important thing?
It just flat out, I think that is the biggest vector to speed that serverless brings to the table, right? Like the fact that you can cherry pick components of your customer or product by relying on other people's expertise, right? So going out there and saying, hey, I know, Jeremy Daly, you have built this great chat service that has, and I trust you to offer me 4 nines availability and a certain performance guarantee. And as long as I use your API, I'm good. The incentive for me to go and rebuild that elsewhere is negligible. Like it doesn't help my business to go and rely on anything else. And I think what that basically does is you are now recruiting an entire collection of experts, of really deep domain experts, to be part of your operational team, to be part of your development team, right? They're continuously improving their portion of that tiny little product and making it better to move faster. The scale is getting better, the performance is getting better, the capabilities are getting better, while you innovate on the part of the stack that you want to. And what's fascinating for me is,
yeah, so I'm just going to stop it there again because I think it's very interesting. The part that's very interesting about that is that's the part that he's saying is the most valuable speed-wise with serverless, is that the thing that ends up happening is that you're relying on a collection, like he said, of different third parties. And so by kind of stitching those together, you're able to then offload all the responsibility of actually running these things. So for instance, we talked about this example of having DynamoDB trigger to a Lambda function to an SES. And if we could just basically abstract that away to an API which handles sending an email, and we just give it a simple input, which is the email address, and everything else is handled in the background for us. Those type of integrations are great. That use case that I just mentioned might be a bad example, but going to like an authentication, or let's say that you have a service is a SaaS service and it has to actually make payments. Having an abstraction over the payments, maybe it's even an abstraction over Stripe to make it even easier to use, and then relying on that abstraction allows you to switch your focus from having to recreate an entire Stripe application that handles payments, the receipts, refunds, all those things, subscriptions every month, and that payment processing that's happening and how that's taking place. So avoiding all of that, relying on a series of APIs that handle that for you, and then switching your focus to what actually matters, which is not creating really good billing system, because that's been done millions of times, but focusing on your unique product offering to the market. And serverless and this kind of service full thing they're mentioning which is taking it beyond just serverless, which started as functions as a service and then moved into fully managed services. And now they're talking about serviceful, which is basically utilizing a collection of different things together. And it may not even be AWS services. It could be things like Auth0 instead of Cognito, or it could be Cognito, or some other new platform that comes out, or product that comes out, or API that comes out in the future, which you can then stitch together with your existing AWS resources to then move your focus back to your actual product.
Is that is the true vision that we all had when we went on microservices development as well, right? You can do independent development of different pieces. They're all small pieces loosely joined that talk to each other, and they can innovate separately. The only difference is this is not just your organization sitting and doing it, your 2-person startup. You have now 22-person startups and AWS innovating on your behalf just to make your product better, right? Like your 1 millisecond example is a great one. Like if you were a startup who was running on us today and you happen to use Lambda for your backend compute, your bill just got 40% cheaper, which you can now pass on as end user savings with you doing nothing. Like imagine how much work you would have to do to go and get that behavior over there. And just one more thing, Jeremy, since you brought that up, I do believe the true power is going to be connecting all these SaaS services together and getting them to interconnect a lot more. You're starting to see this with some of the bigger ones, right? So Twilio, Workday, Atlassian, they've all added this programmable SaaS component to them, right? They've got these Lambda-based extensions that they're showing up, like Twilio functions and Netlify functions and others, that allows them to add just a little bit of logic to them to then talk to other services via API calls and kind of build forward over there. So I think just the flexibility and power this enables is really, really cool. And the fact that you can swap out one API for another is quite a testament to the whole dance around, am I really locked into a particular provider or not? Because it's quite easy to change an API call more than anything else.
Right. No, absolutely. And the speed of that is, just the speed.
Okay. Well, I just wanted to try this out. Basically, this is episode number 80, Revolutionary Serverless at reInvent with a J. It wasn't the entire thing. It was just a small snippet of it. There's a lot of takeaways from this, so I definitely check out Serverless Chats. This is only episode 80. There's 81 actually episodes, so if you actually want to go through those, I definitely highly recommend it. This podcast is really great because there's a breakdown, there's a YouTube video, and they also have the transcript. So you can actually read through, as I've been doing on the stream so far, and then actually following along with it, pausing, and then talking about it. There's been a lot of good stuff in here before I actually started the stream, and there's a lot of stuff after this as well. I'm just going to leave it here, end it for the night. Thanks for watching, and I'll see you